Okay, good evening, everyone.
Amen.
Welcome to the bootcamp. This is the first bootcamp we're having for backend development. My name is James Inas. I'm a software developer with Maxify, and I'm going to be an instructor for this training. So basically, we're just going to have for an overview for the first week today. We're going to be having an introduction to programming. So without further ado, I think we should just jump in right away. So I'm about to share my screen now so we could start, okay? If you have any question, you can just drop in the chat. For now, we won't be taking further questions, but we'll take these things in phases. After the first section or the first phase, we'll give a 5-minute break, and then we can ask questions, then we move forward. So I'm about to share my screen right now so we can start. So guys, let me know when you see my screen.
Yeah, you can see your
Can you all
screen.
see my screen?
Yes.
Okay, so before I start, there's a famous quote by Steve Jobs that says, everyone in this country should learn how to program because it teaches you how to think. So let's start with that. So programming is a very powerful profession, and it actually gives us the ability to think and solve problems. So let me move over to my slide. Can we all see my slide?
Yes.
Okay, fine. So this first lesson, we are going to be looking at basic introductions. What is computer? What is programming? What is computer programming? Types of programming? How is a program built? Programs and data work together. Types of programmers right? Understanding programming. So basically, these are just the highlights of what we're going to be doing in this first lesson. Okay, so what is computer? Okay, so what is computer? A computer is a data processing tool. Can we all hear me?
Yes,
Yes,
can
sir.
hear you.
Okay, yeah. A computer is a data processing tool that has the ability to perform logical operations and also change program. So the key word here is data processing. Calculator is also a machine, but it's quite different, right? Because it processes data, yes, but it doesn't perform logical operation. So computer has an advantage in that regard. Then also computer has the ability to change programs, which means you can run different programs in your computer, right? So a computer has to fulfill this requirement. First, it has to be a data processing tool. It has to perform logical operations. It has the ability to also switch between data. So that's basically the definition of a computer. And computers really work on data, essentially. That's what they do. Data is just like the ingredients computers make use of before they can actually process whatever problem they want to process. So what is a program? A program is a set of statements that a computer follows in order to perform a specific task. So when you write statements, you feed it to the computer, and then the computer processes it, to give you an output. So a program is basically those statements you write that computers follow in order to perform a task. So essentially, when you write a program, you're basically writing statements, and these computers have the ability to understand the statement because they've been programmed to do so. We'll get to that part where other softwares help you run your statements. Then quickly, we are going to be talking about computer programming. Computer programming is a set of activities, including writing a program in a programming language, then compiling it. It is not just enough to write programming, you have to also compile it. and then linking it to the relevant libraries to prepare the executable code, and then testing the program to remove all errors, including syntax errors, logical errors, and computational errors locking inside the program. So essentially what we're doing is, after writing your program, you have to be able to compile the program. The computer does that. Then we execute the code, we test the code, we remove errors. These are all the processes that involves with computer program that computer does, in every program. Okay, so essentially these are all the tasks. It cuts across just beyond writing statements. It involves testing. It involves checking of errors. Then it also involves executing the code. And then it's beyond that, when you write programs, you also iterate and make improvements, right? Then next, we're going to be talking about types of programming language. Essentially, there are two types of programming language: the high-level programming language and low-level. For the high-level programming language, these are languages that we write. They are human-readable languages like Python, Java, Ruby, PHP, JavaScript. Then we have the low-level programming language, which are basically assembly languages like Lisp, for example. They are initially developed in the 1940s and 50s. These languages are they are more tended towards machine code, because at the end of the day, your programs are just ones and zeros. Okay? Are we together?
Yes, sir.
Then how is a program built? So essentially, when you write statements, these statements, bunch of statements are supposed to be executed. Now, there are two softwares that help you execute your code. One is the compiler, and then two is interpreters. So the compiler helps you compile your code and then execute, while the interpreter does that as you write the code. It does it automatically. That's the difference. The compiler compiles it once at the same time before executing, while the interpreter has this built-in real-time interpretation before the code is being rendered. Programs and data work together. So like I said, computer is a data processing tool. Now, every program in the world needs data to be able to process. There is no point writing programs, or programs cannot make any sense without data. So data is the ingredient for any meaningful program. Without data, programs would be a lot less useless. In the real world, data takes different forms. Programs have data types to represent this real world data. So essentially, the programs or computers, let me say computers, understand data. They don't understand anything else. They see the world as objects. They essentially understand data. And then programs, since we write instructions to these systems, they are supposed to process data. The instructions is basically inputs. The data is basically inputs that runs into the system for processing. So types of programs programmers write. Now, when you want to write a program, you have to understand the type of program you're supposed to write. For this bootcamp, essentially, we're talking about web applications. So the kind of program we're going to be writing in the subsequent module is a web application. But beyond that, there are different kind of programs we can write. We have terminal programs. These are programs that run in the terminal, like in your console. They basically do automations for you. Then we have scripting programs. These are programs where, for example, you write a script that converts a PDF document to a Word document, or you write a script and deploy to AWS Lambda to do some clone jobs or automation on your behalf. So essentially, scripting programs are usually important or useful if you're working in an office environment. As a Python programmer, you can basically write scripts in the office that does your day-to-day tasks by automating stuff. Then, like I said, web application is another one. Mobile application is also another kind of programs you write. These ones run on mobile phones. Then we have client server applications. These are applications that mostly reside on your desktop. They don't require external servers. They run on your own local servers, and then they use your like graphic user interfaces instead of browsers. So you normally install this kind of programs on your desktop for them to be able to work properly. And they also have their runtime that makes the code executable. Okay, so I'm going to show us a diagram now, basically an illustration of how programming works essentially. Can we all see my screen?
Yes, sir.
Yes, yes.
I'm actually on a whiteboard. Can we see the whiteboard?
Okay. Sorry, Mr. James. Sorry, we have Wale with his hand up. I don't know why. Wale, can you drop your concerns on the chat box? Your hand is up.
Yes, I wanted to ask a question. That's why I raised up my hand.
Okay, Wale, can you just hold on? Let's you can just type your question.
Type your question, please. You are no longer sharing your screen.
Yeah.
Okay. Wale, please type your question and it will be attended to shortly.
Can we see my screen now?
That's not come up yet.
Okay. Sorry.
Was in the whiteboard. Oh, okay, it's gone now.
Okay. I'm trying to. Okay, can we see? Can we see my screen?
Not yet.
Okay. Okay, before then, I'll come back to that. I just kind of think it froze on me. How about now?
You can see the whiteboard.
Okay, let's just continue.
Yes, you can see your screen now.
Okay.
We have a question from Wale in the chat.
Okay, so do I go ahead to read the question for you?
Okay, just read the question so we can.
Okay, can you please explain the difference between terminal and script programs?
Okay.
The difference between terminal and script program.
Okay, essentially, like I said, terminal programs are programs you write that enable you perform automations in your terminal. For example, let's say you want to start a project. There are some scripts you can download, that allows you to automate the setup of your project, like imputing the project name, the project dates, version, and all of that. And also there are scripts that, terminal scripts, for another example, are scripts that are supposed to help you probably improve the look and feel of your terminal. So all of those kind of scripts some of them are built scripts. They work essentially in the terminal, right? So these are just, there are so many of them. While the other one you said is what? Scripting programs, right? Scripting programs. For example, let's say you want to automate the process of transferring data from your PDF or from your Google Sheets, into another program. Let's say Notion, for instance. If there's an API for that, you can actually automate that process instead of copying and pasting the cells from your Google Sheet directly. So scripting programs are basically used for automations. Another practical example is, let's say you can write a script and deploy to AWS Lambda. So what the script does in Lambda is it can be triggered at certain intervals to perform certain automation, maybe check on if there's a new document that has been submitted or an image that has been submitted into your S3 bucket. So you can actually write a script to check that every day. Or you can even write automation script, for example, to check all your friends that have certain birthdays in March. So if they have their birthdays in March, you could actually send them messages, happy birthday messages. So these are different kind of scripting programs. They essentially work on automation. I don't know if I'm able to answer your question. Are you clear?
Yes, he said yes. So you can go on. Thank you.
So let's quickly move on to data. Like I said, programs need data. What is data? Data is facts and figures about entities. An entity is a person, place, or thing. So data is essentially numbers, characters, strings. They are just facts and figures about entities. And these entities can have descriptions about them. Like a person entity now can have a name, age, and all of those descriptions. So all of those things are data. Now, types of data, we have string data, integer data, floating point data, Boolean data, list, class, and collections. We're actually going to be seeing a review of this by the time we start the actual coding. These are just introduction. So strings are typically sequences of characters, integers and numbers. Floating point data are just fractional parts, right? When you have 2.3 and all of that. Boolean data is just true or false. Class, list, collections, these are just essentially groupings of data. They actually are kind of like an advanced form of storage of data that does from the basics or the primitives of data. We'll look into that more in the subsequent lessons. How we get data into programs. One, through console. Now, essentially, like we've established that programs need data to perform certain operations, right? So how do we get data into our program? Because data are actually ingredients that programs need to perform operations. One is through the console. When the console is also known as the terminal. I don't know if any of us are familiar with it, but I guess some. So the console, you can actually input data through the console into your program. Then through program files. When you have a file, you can actually declare data in your file. So that's another way to actually get data into your program. Then forms and templates. These essentially works when you're building web applications or graphic user interfaces. You need forms to get data into your programs. When you submit a form, you're essentially passing data and you're calling a program to actually process those data in your form. Then through templates, HTML is a perfect example of templates. When you click a button, when you hover over an element, all these interactions you do on a page, it's also a way of sending data into your program. Then running programs. I just said that if you're writing a program, then databases and other systems, you can actually get data through a database by making requests to certain APIs. And then other systems also involves making third-party requests. All of these things are ways to get data into your program. Because like we all said, data is needed for us to process and then get certain results. Computers, why do we process data? Computers need data to process. They process data to make information. Without data, computers would be useless. Data is all around us, and they take different forms. Programs use data in operations and expression. How do we store data in programs? Same way we receive data, we can actually process data, post them through the command line, program files, variables, databases, and other systems. Now, the third module, essentially, the third lessons in this module is Hello Python. What is Python? We're going to be looking at why Python and how to run Python on your machine. But before we move forward, I don't know if we've all installed, you can just type in the comment box if we've all installed the software I sent to in the WhatsApp group for us to install. Just comment in the section box if we've all done that. So what is Python? Can anybody just tell us, maybe briefly, you can unmute your mic, what Python is? Can we see my screen?
Yes, sir.
Yes,
Okay. I just changed tab. Can anybody tell us what Python is?
Hi, Wale. Hi, Dominic. Hi, Obseni. Can you share what Python is? I mean,
Yeah, sorry. Python is a programming language that is mostly useful for backend development. It's also very, very useful in data science and automations.
Okay. That's correct. Let's move on. So Python, can we see my screen?
yes, please.
Okay. Python is a general purpose high-level computer programming language that allows programs to create applications, web pages, and many other types of software. So essentially the keyword here, it's a multi-purpose language, high-level language, easy to understand. The syntax are clear, precise, good for beginners, and you can write programs in the field of web development, automation, data science, AI. So it's very, very powerful with all of those stuff. Now, why Python? Like Python is free. Python is simple. Python is available on most platforms. Python has an extendable library and is pretty much popular. So have we all installed some of the softwares I sent? Can you just indicate in the chat box before we continue?
Wale said yes. Hussein said yes. Dominic, we're yet to get your response.
Do we have any challenge with the installation?
Dominic also has.
Okay.
Hussein said he's facing network issues. It's not opening. But,
what is not opening?
Hussein, what is exactly is not opening?
Yes, sir. I installed it, but anytime I try to log in to open it, it is not working. It will just be rotating or something like that. I don't know whether it's my network.
Okay. We'll see. We'll come over to that subsequently. Okay, let's just move on briefly. We'll come to that. So let's discuss basic programming concepts. Can we all see what I'm presenting on basic programming concept?
Yes.
Okay, so number
Yes, sir.
one, in order
But
to
it's
write
not that
efficient, huh?
It's not clear. The right top is not clear.
Yeah, it's fine. Let's just Zoom for some reason doesn't allow you share tabs. I would have preferred if we can share a single tab. Okay, so can we see this?
Yes.
Okay, this is clear, right? So we're going to be looking at syntax, tokens, symbols, semantics, keywords, expression, statement. Can we see my slide? So these are the 7 basic programming concepts we are going to be looking at in this session. Are we together?
Yes, sir.
Okay. So first, let's talk about syntax. Syntax is just a rule that governs the structure of a program. Syntax essentially tells you about the do's and don'ts. This is how you declare a statement or a variable in this programming language, and this is how you declare it. For example, in Python, you don't need to use a keyword to declare a variable. While in JavaScript, you have to use the keyword var or const to define a variable. Are we together? So syntax is essentially just the rules that govern the structure of a program, okay? So let's talk about tokens. In programming, tokens are the smallest units of syntax that the language recognizes. These tokens are building blocks used to construct statements and expressions. Common types of tokens include keywords, okay? Keywords are things like prints. These are reserved words in programming language. Another example of token is identifiers like variables. Okay, these are examples of tokens. Functions, classes. These are examples of tokens. Literals like 2, 3, 4 strings. So token essentially is everything. It talks about everything, every unit of syntax that a language recognizes, whether it is operators, symbols, punctuations, functions, classes, variables, all these things are tokens, right? They are the smallest units. Anything you see in programming, any symbol, any keyword, you can generally refer them as tokens individually, even comments, okay? Now, let's talk about symbols. Symbols are characters. Like if you see your plus, minus, division, all of these things are symbols. They are very essential in programming because they help us do things like they help us with making operations, right, in your program. Then semantics refers to the meaning or interpretation of symbols. So when you read code, one of the characteristics of a good programmer is that you read and then you write code. You don't just jump into writing code. So when you read code, you need to understand what the code is talking about, and that's essentially semantics. Keywords are reserved words in programming language, like we have established. For example, print statement, if and else statement, these are keywords, right? Now let's talk about expressions. Expression is a combination of values, variable, and operators. When you have an expression, how do you know it's an expression in a programming language? An expression generally resolves to a value. If you see 2 in a variable, if you see 3 or a string, anything you see that generally converts to a value is known as an expression. Then we move on to statement. A statement is a unit of code that has an effect, like creating a variable. So when you see prints, for example, in Python, all you're seeing is a statement. A statement generally evaluates or gives instruction to your program to do certain things. So statement code, they are essentially action words. While expression resolves to a value, there's a difference. It's very important we know the difference because we'll be writing a lot of statements and expression. So expression are important in our program. They are actually intertwined with statements. Most times when you have statements usually have an expression behind it or immediately after that statement. So expressions are essentially values, your data. Why statement is just a keyword like print. It does something to your program, okay? So can we see my next slide?
Yes, sir.
Okay, so let's quickly talk about core programming construct. This is very, very important. We're going to be looking at data, types of data, variables, operators, and functions. Now, there will be a lesson notes at the end of this training. We'll all get it. So don't mind my speed. We just have to move fast so that we can meet up with time and also have time to do some practical coding. Are we clear?
Yes, sir.
So let's talk about core programming concepts. The first one we're going to be looking at. First, each programming language normally has their own structure and construct. Now, they help us understand how to design and structure our programs appropriately. It is then up to the developer to ensure that they learn the appropriate programming language construct. So every programming language has all of these constructs. They are basic principles of a language. So the first one we're going to be looking at is data. Data as value. A value is one of the basic things a program works with, like a letter or a number. So this is one of the constructs in a programming language. Data is very, very essential. I can't overemphasize on this. All what we'll be doing is data, 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 and data is everywhere around us. Now, types of data. There are different types of data. We have the simple data types and we have the complex data type. Basically, the simple data types are integers. Things like numbers, right? So I'm going to switch my screen now to Jupyter Notebook. Okay, are we together?
Yes, sir.
Okay. I'm going to switch my screen. Can we all see?
Yes.
Can we all see now?
Yes, we can see your screen.
Okay. All right. So integer data type. This data type is used to denote the storage of numbers, essentially. Most programming languages allow for storing numbers. So this is an example of an integer. Can we see total score is 1,000. So 1,000 here. Can we see my screen or should I zoom a little bit?
No, we can see your screen. Please go on.
Okay, so we have 1,000, which is an integer, and then it is stored in a variable. This is a variable called total score. So this is an example of an integer, okay? Then 25 is also an example of an integer and all. So year of birth, so integers can be negative, they can be positive numbers, right? So these are all examples of integers in programming language, and integers are data types. Next, we have floating data types. This data type is used to denote that the identifier can store a number with a decimal point. When you hear identifier, it's just trying to say variables, right? So because in programming, variables are very, very essential. We'll go over them much, much later. So floating type, example of floating type, 12.5. Like, for example, diameter of a pizza in inches, for example, can be 12.5. Pi in mathematics can be, I think, 3.5 or so. Then we have bank account balance. This is minus 1.23. These are just examples of floating data types. They are fractional parts, right? Then we have string data type. This data type is used to store strings of characters. For example, your name is a string and is also a data type. So practical example is mood. Even normal characters like emojis are strings, right? Eat cake because why not is an example of a string data type. Then you can declare a variable with an empty string. It still works. Then we move on to Boolean data type. The Boolean data type represents data that may be either true or false. A Boolean variable in Python may only hold either the literal value true or the literal value false. So what this is saying is when you have true or false, these are data types in programming, and they are also known as Boolean. Now, one of the major reasons why we have this type of data type in programming is because we want our programs to be able to make decisions, right? Now, as human beings, we have the mechanism to make decisions inbuilt by default. For example, when it's raining and you want to go out, you can just pick your umbrella in the rain and go out, right? So that to avoid the rain. So, but for programs, they don't have, or computers don't have the ability to think that way by default. So you have to ensure that you test those scenarios, and true or false are ways we can actually make programs. Now, one of the ways we can make programs think logically, right? So that they can perform logical operations. Remember, in our definition of computers, they perform logical operations as well. And they do that through programs, right? So Boolean data actually helps us with that. That's why we have them. Then, for example, look at this code. Is it raining? The value is true. So now with this, you can actually make decision in your program. So if it's raining, for example, go out with your umbrella, or stay indoor, So these are ways you make logical decisions in your program. Are we in trouble? False. Now, if we are not in trouble, then we can go out, something like that. Okay. Let's talk about variables. Now, variables are very, very important in most programming language. Now, I'm going to tell you why they are important. When you write programs, you normally need a place to store your values, your data, right? Whether string, Boolean, numbers, you normally need a place to store them temporarily in your program. So variables help us do that. They are just a name of some location in memory that can hold data. So I usually call it variable box because it's just a box in memory with a name on it to represent the data you have inside the variable. So variables in any programming language are used to hold data that can be used at any time during the course of the program. Normally, these variables are listed as identifiers of a particular data type. So a variable can either be a string, Boolean, number, integer, or floating point. Let's have a quick example. So favorite song. This favorite song in Python is a variable. And then the value is 12 by Kiss Daniel, right? So this is a string, and this string is a value inside favorite song. Favorite song is now the variable, the container that is holding this string. So we can now say that favorite song is a variable. It's a location in memory that is holding this string. Now, as you begin to run your programs, you would need to remember each of your data in your program. So variables help you keep track of your data. It just helps you save them temporarily. It's not a permanent storage anyway. It just helps you in the execution of your program. Now, do we have any question before we move to the next construct?
I don't think there's a question on the chat box already. So we'll go on.
Okay. Okay, let's move on quickly. So next thing, we're going to talk about operators. Operators are special characters in a programming language that operate on data stored in variables. Some operators require 2 data values and some require 1. So operators essentially, now we talked about statements in programming, right? An example of a statement is an operator. For example, a plus operator is a statement, because what it does is it adds two operands together, right? Two values together. Now we're going to look at example of operators. We have the assignment operator. So what this does is it assigns value to a variable. And a practical example is this. We have this variable, my occupation. So I'm trying to read this code now. So this is a variable called my occupation. And this assignment operator, what it's saying is put this string inside this my occupation variable. So this is an assignment. So what it does essentially is to say, it's helping me add this string into the variable. Okay. So arithmetic operators. Arithmetic operators perform mathematical calculations on data. Now, these are examples of arithmetic operators. We have the plus operator that does addition of numbers. We have subtraction, the minus operator. We have multiplication, which is the asterisk. Pretty much basic arithmetic operations we know in primary school. Then we have the unary operator. Unary operators are operators that operate on a single value. The plus and minus unary operator are like positive and negative, right? So this is an example of a unary operator. When you have a variable plus 5, as when you have a number, and then you have this plus 5 on it, you're essentially saying that add plus 5, assign it into this positive number integer. Then minus 10 to assign it into this negative number integer. So the minus and the plus here, these are unary operators, right? There are other examples, of course. Now, comparison operators. Comparison operators compare two values and return a Boolean result, true or false. Let's take a look at this code. X is a variable, and we assign the number 10 to it. 5 is also a number assigned to the Y variable. So comparison operators, essentially, example is equal to. So we can check between these two values if 10 is equal to 5 using this equality symbol or operator. And if we check 10 equals to 5, we are going to get false, because normally what they do is they return Boolean values, true or false. So we use them in our programs to compare two data to see if they are equal or not equal, or greater than or less than. So these are all examples of comparison operators. We have the greater than, we have the less than, equals to, we have the less than equals to, the greater than equals to, we have the not equal to, and the equal to. These are some of the examples of the comparison operators. Then we have conditional operators. Conditional operators operate on two Boolean values. For example, you look at this code, value 1 is true, value 2 is false. So now, if we try to compare value 1 and value 2 together, what it's trying to say is true and true. If this value and this value are true, then the result is going to be true. But if this value 1 and value 2 are not the same, then it's going to result to false. Like in this code now, value 1 and value 2 will be resolved to false, because the value in value 1 is true, while the value in value 2 is false. So the AND operator tries to check to see if two data types result to true values. In this context, this is not the same. So it's giving you false. While this example, for all operator, we are trying to see value 1 or value 2. Now, what this does essentially is to check between this and this. So essentially, the OR operator is trying to pick between this value and this value. So, and most times it goes, or always it has to go with the true value. So the result is going to be true for this line of code. functions. Let's quickly talk about functions. Okay, so a function is simply a name section of a code that performs a specific operation or task. We can write our own function, or we can choose from a library of creating function. Most programming languages come with built-in functions, but libraries can also be imported. So a function essentially is just a grouping of code, a named group of code, right? So the reason why we have functions is just to essentially help us group our code. So, and this code are most times they are reusable. So in programming, in Python, you typically define a function with the def keyword, while in JavaScript, I think you use the function keyword. So let me explain what this block of code does. This is if trying to define a function in Python with the def, starting with the def keyword. Remember we spoke about keyword in the previous section. Then this is the function name, and these are the parameters of the function. Now, parameters are just values. So this, in this case, if this is supposed to be a live function, it's supposed to accept data into it. That's why we have parameter 1, parameter 2. But not all functions actually accept data. Some functions actually just run on their own without accepting inputs. So, but in this case, this function description has parameter 1 and 2, which means by the time we call this function is going to accept data. And then whatever comes inside is now the function body. All this is the function body. So when you're trying to define a function, you use the function keyword, and then the function name, you give it a name, then this parenthesis, and then the parameter in the function. The body is where the lines of code, is where you write the lines of code. And that is what really matters, because if you have a function without lines of code, it means the function will not do anything. So the lines of code, the body of the function is where you put in all your algorithms or all your statements, so that the function can actually run your code. This is an example of a function. This function is called calculate laughter level. I'm going to just explain what this function does briefly. This function calculates laughter level, and when you call this function, because functions are also called, not just declaring a function, you have to call the function after declaring the function, because defining the function does nothing. It's just like you're structuring your code, right? You're just structuring, it's just there. But once you write it, you now have to call it. So this function, for instance, calculate laughter level, is going to accept an argument, but for now, this is a parameter, jokes told. Then it's going to accept an argument, which is an integer. Then it's going to return a description if the laughter level is high. So now, if you move down to the body of the function, you will see that whatever input that this function receives is going to multiply it by 2. So let's say if you call the function with 2, it's going to multiply it by this value 2, and then it gets the laughter level. So now we are now checking to see if the laughter level is greater than or equals to 10. Remember, if you add 2 here, this is going to be 2 times 2, 4. So if 4 is greater or equals to 10, we will now have, if this is true, which is false in this case, now since it's false, this is the block of code that will run. But if the value we have in this laughter level variable is greater than 10 or equals to 10, it means that the joke is funny, and then everybody's laughing. So what this function does essentially is just to calculate laughter level, and it accepts an argument. The argument it accepts is a number, and once we get that number, we do a processing. We multiply that number by 2 to check the laughter level, and then once we have the laughter level, we can now compare if it's greater than or equals to 10. So the benchmark is if it is 10 or greater than 10, it means the joke is funny, right? And the laughter level is high. But if it is less, then we'll say the joke is not funny because people are not laughing. So that's what this function does essentially. And if you call this function with 3, for instance, the first output here is, oh no, we need a better joke. You're not cracking us up. But if we call it with 5, 2 times 5 gives you 10 from this processing. And then the second function now gives you, you've got everything rolling on the floor. You've got everyone rolling on the floor laughing. So yeah, that's pretty much with function. At this point, I'd like to give us the opportunity to ask questions. Then we'll move on with the practical session, which is the code. Can we hear me?
Yes, I can hear you.
Do we have any question? Can anyone hear me?
Hello, sir.
Yeah, can you hear me?
Yeah. So my question here is under core programming construct, you mentioned complex data type, and give example of types, but didn't give example of.
I'm not hearing you clearly.
Okay, are you hearing me now?
Yes.
Okay, I said under that simple data types,
yes,
you give examples of integers as part of the simple data types. Then
Yes.
what about the complex?
Okay. Thank you very much for that question. We have complex data types, but we'll be looking at complex data type next week. We're not going to run that today. We'll be looking at it next week. Okay, so if there's no question for now, we are going to go on a break, on a 10 minutes break, 5 to 10 minutes break, then we'll come back. Is that okay?
It's okay, sir.
All right, so
Yes,
we'll come
okay.
back. We'll come back around 6:25.
6:25. Okay.
6:20, right? Are we together?
Okay, sir. 6:20.
6:20. We are coming back 6:20.
Okay.
Sorry, that's 15 minutes, right? That's 15 minutes break.
Huh?
Is that like 15 minutes?
Sorry?
What time are we coming back? You said it's 15 minutes. That's 15 minutes. That's more than 10 minutes.
Sorry, I'm not hearing you, Wale.
All right, can you hear me now?
Yes.
Yeah, I said that's 15 minutes. That's not 10. That's not 5 to 10 minutes.
Okay, that's 15 minutes. Okay. All right, so let's just meet at 6:20 then. Let's just meet at 20. That's 15 minutes time.
All right.
Yeah, that's 15 minutes time. Okay, welcome back, everybody. I actually was trying to set up, there's a diagram I skipped initially regarding understanding programming. So I'm trying to get it up and running. So give me a second. Only the next 2 minutes. But if anyone has a question, you can ask.
All right, that's fine. So maybe a quick one, if there's a question we can ask why he's trying to set up. But I don't know if maybe we can give a brief feedback on the progress of the class so far. Mr. Wale, Mr. Husseini, Mr. Dominic, can we say one or two as a form of feedback?
Hello, sir.
Okay, yeah, go on.
Actually, for the first time, I am attending a programming class like this. Although I don't have any experience though, but I am getting some light. And if we continue like this, I think I am going to gain a lot. By the way, I am just on my way home, so I just like trying to like just join and cope with you guys before I get home. So
Okay, please, you should try to get home early because you can't do this class in transit. But I mean, thank you so much for your feedback, and I hope that you will pick up from here and you would have a story to tell going forward. Thank you. Mr. Wale, the Dominic, you want to share it before instructor comes back?
Hello, everyone. This is Dominic.
Hi, Dominic. Hi, Dominic.
It's been good so far. I like the fact that we started from the foundation. It will, for those who don't have that knowledge, to provide the basic knowledge so that when you start programming, things don't sound weird to you. Then for those who already have, it serves as a reminder. I hope we'll do more and we'll achieve more in the coming classes. Thank you.
All right. Thank you so much. So Wale said he's okay with the flow. I mean, yeah, we started from the basics and it's good that every house is built on a solid foundation. So I'm glad that you are having a good time learning. I hope for the better.
Okay, thank you, everybody, for the feedback. So there's this slide there's a diagram rather I'm supposed to present initially when we had the hiccups. So I'm going to go over it briefly because it's very, very important, especially for the newbies who don't know much about programming. So I'm going to share the diagram, then have a little explanation about how all of these things fit together. Then we'll move on to the installation part. The first part I sent on the WhatsApp group was just like the basics. We're going to do some more installations moving on. Then that's how we'll progress. So are we good to go? You can just indicate in the comment section. All right. Can we all see my screen now?
Yes, we can see your screen.
Okay, fine. So Try to zoom in a bit. Okay. So essentially, this is an overview of programming, because every program has three parts: the input part, the processing part, and the output. And you can see it's depicted here in the diagram. So we're going to go over them one after the other. So for the inputs, we've already established, we have data types, we have data sources, we have data storages. So the input essentially is all about data, right? And we've established that data are facts and figures about entities. So then the third diagram talks about files, consoles. These are how we get data into our programs: files, consoles, in-program, HTML templates, and databases. Then coming down to the processing part, which is the algorithm, we have an acronym called SCA. So I'm going to explain what SCA means essentially. So the first one is structure. So every program should have a structure. So you can think of the structure as your project folders, your files. So by the time we begin backend development proper with Django very soon, we're going to be structuring our code, right? We're going to be following certain architectures. Like for Django, is usually called the MVT architecture. For Node and Express, typically we have the MVC architecture. So if you're building for web application, you have to structure your code. You have to structure your project. So structure is very, very important. Once you structures really is just like how your code are being arranged, the modularity, how you define your classes, how you define your objects, how you define your functions. All of these things put together make up your code. Then the second acronym, the second letter is the construct. Construct essentially is what we've just learned: all the syntax, all the things like variables, data types, functions, and the likes. So all of these are the constructs. Next week, we're going to be looking deeper into advanced data structures, complex data. Then we're going to be looking at things like loops, if and else clauses, all of those stuff. So these are constructs of programming, right? So you need to understand all of these things because they help us in processing. You cannot process without understanding all of these things. You can't write efficient code without understanding all of these building blocks. So essentially, they are the building blocks of programming, right? Then you have the actions. The actions are essentially your statements, your operators, all the things that your code does. And one of the ways you can easily identify a statement is through a keyword. And there are so many of them. In Python, we have a lot of keywords. We have the for loop keyword. We have the if and else keyword. We have the print keyword, and a lot of them. So these keywords help us perform operations. They help us with processing. Similarly, we have operators. We just discussed operators. These operators also help us with processing. So by the time we begin to run all of those things together, these things are now the action that runs our code, right? They speak to the compiler, and then the compiler executes, the computer executes. And then lastly, we have the result. And then that's really the output of what we're looking at, okay? Then that's all about the SCA. So the SCA is just an acronym for structure. Structure is just your folder, your files, your modules, your packages, all of those things. your libraries are even structured, but they might not be your own structure. Now, I don't know if you already know, but for those who don't, programming, there's something called libraries and frameworks, right? Libraries essentially are code, classes, and method that helps us execute certain functionality in our code, right? They are defined by other people. You can actually create your own, but these are pieces of code that are reusable. They've been written by and tested by other people that you can use. So that in itself is a structure, a body of code, because it involves files, classes, modules, and all of those stuff, right? Then we have frameworks as well. Framework is more like a complex version of a library because it does a lot of things for you. It's opinionated. Like Django, for instance, is a framework, right? Because it tells you how to do certain things without your opinion, okay? Now, so that's basically about structure. We've talked about construct, actions are the operators, the keywords, and all of those stuff. Now, the last part of the processing is the output, which is the solution and the information you're trying to solve, the solution you're trying to solve, or the information you're trying to render. And now, depending on the kind of application, if you're writing a web application, solutions or outputs typically will be via HTML template. For instance, let me give a brief introduction of how the web works. In web programming, we have something called client-server architecture, where the client sends requests. The client in this case is the browser. You type a link in your browser, and then you send a request to the server sitting somewhere, and then the server picks that request and then goes to process that request. There's a code that's going to respond, a function, for example, or a class that's going to respond to that code and then send back an output. So even the web, the way it works, how the web works is still is still essentially modeled via this input processing and output system or pattern. Because when you type an address, for example, maxify.com, you're simply putting in you're passing in data, which is an input. Those addresses, URL address, are basically input data, right? They are strings. So when you pass it into the browser knows how to send the request, execute it, and then send it to the server. So the server now picks up that URL, processes it, goes to your code. The server actually has two tiers: the server where you host the files and the server that actually is running your website. That is your code, essentially. So the server that hosts your website sends the redirect the request to your own application that is sitting on top of the server, and then your application picks it, checks the URL, picks what it needs to pick, and then processes it through a function or a code. Sometimes it goes to the database to pick files, then it gives you an output. Now that output is your HTML template. So you can now see that it still models the input. It still models the input, processing, and output procedures. Then even if you're also dealing with mobile apps, similarly, they work the same way. Scripting works the same way. Client-server application, all of these things, they follow the same pattern. And what they render, like for scripting applications, they might not return an HTML page, but they might help you send messages. For example, you can write a script to go and check your contacts in the database, your friends in the database stored somewhere, check their date of birth, and then if their date of birth is today, for instance, the script can now send happy birthday messages to them. So this, for example, is not the output now you're sending is not really an HTML template or whatever to the browser. You're sending a JSON, for instance, or a text message, So these are various ways you send output. So output can come via HTML, via text, via JSON. For JSON example, let's say you're talking to I don't know, for some of us here, we might not really understand APIs, but we're going to get to that in the next class, hopefully. You can also send, there's something called JSON. It's actually a format of exchanging data using certain ways. So JSON is JavaScript object notation. So what I'm trying to say in essence is when you're sending data, when you're sending outputs to in a program, it's not just HTML templates. It could also be text. It could also be JSON. So we're going to be looking at all of those things subsequently in the next class. So if you have any question regarding this diagram or this what I've just explained, we can just quickly ask so that we can continue.
Sorry, hello. I don't know if you can hear me.
Yes, I can hear you.
Can you hear me? Okay. Yes. So I just wanted you to recap that flow. Can you show the screen again where you?
Okay.
I'm trying to, yeah. So yeah, I'm trying to link I'm trying to link the flow together. So from input, so how does that work? So you have input go to processing, and you also have another leg going to, okay. That means the other from the very top, please, for input data, yeah. So is that an explanation? The coily arrow to the right is just an explanation, or
yes,
it's a breakdown? Is an explanation. Okay, so
yes,
the main flow is from input to processing and to output, right?
Yes.
Okay, all right, thank you.
So the arrow to the right is just an explanation of more details about each of the 3 stages. So every program essentially that you write follows this format. They follow this input processing. And so where you do the bulk of the work is in the processing. That's where you now need all of the programming constructs like the variables, the data types, the functions, and the classes. So when you understand all of those things, then you now know how to combine them in whatever problem you're trying to solve.
Okay, what do you mean by consoles in this scenario?
Okay, the console is also known as the terminal, right?
Okay.
Do you know about it?
Yeah, I know the terminal.
So it's a command line interface where you write. It's not a graphic, like when you open your browser is an example of a GUI, graphic user interface. The console is a command line interface. It's just text. You just write commands to it, and it prints out. I'll show you an example of one very soon after this. So can we move on?
Yes, please.
Okay, so now we're going to move on to the next section where we're going to be doing some review of the installation. So have we all installed Conda into our local machine? Have we all installed Conda? I need a response now, please. Can we hear me? Okay, so how about Git, VS Code, and Python? Okay, so now, very well. So let's do, for Conda to work appropriately, now this is going to be very practical based. The installation is going to be very practical based. So I want us to for Husseini, you said you're in transit. I think you should, I don't know how you're going to do this, but we need to go practical now. I'm going to share my screen. We're going to be inputting certain commands because installing Conda is not enough. Okay, so let me say, so I'm going to share my screen now so that we can all can we see my screen? My terminal. This is my terminal. I need a confirmation, please.
Yes, we can see your screen.
Okay, fine. So there's a certain command, there's a bunch of installations we need to run now. For those of us who have internet, I'm going to show you some of those commands so that we can quickly run them. Or should I just send it to the WhatsApp group if we can see it there? No, I think we need to complete the installation. After installing Conda, we need to do certain things. Let me go back to the flow. You need to come to, okay. Let me share all my screen. Okay, so are we together?
Yeah, we're together.
Okay,
Yes,
so now,
together.
can you see my desktop, my main desktop screen?
Yes, we can.
Okay, so if you do, just search for Anaconda. Once you've installed Conda, just do Anaconda on your search bar, just like I did. You will see this Anaconda PowerShell. Click on it to open it. Once you open it, so once you open, it's going to show you this interface. So have you all done that? It's going to show you the interface. Now you're going to input certain commands to do certain installations. So the first installation we're going to be doing is Jupyter Lab. So if you just come, so first let's confirm if Conda is installed. Just do Conda -- version. Once you have Conda -- version, it's going to output the version of Conda you're using. Okay, mine is 24.1.2. So clear.
Sorry,
Then
can you please send all the things that you want us to install on WhatsApp, or
yeah, this is I'll send it on WhatsApp now so that we can all.
Thanks.
So we're going to be installing Jupyter Lab. I'm sending it right away. We're going to be installing Jupyter Lab, then Jupyter collaboration, notebook, Jupyter Lab Gits, code formatter, ISO, and the likes. So I just sent it now. Have we all seen it?
Yes, please.
Okay. So now, but it's very, very, okay, all installed from your end. Okay. So essentially, I actually wanted to show us the process. So once we just search for Anaconda in your search bar, once you do the search, click on the Anaconda command prompt and input all of those commands just to do the installation. Is that clear, or do you have any question regarding that? So essentially what we're doing is we're using Anaconda to install Jupyter Lab, notebook, Jupyter Lab Git, and all of those stuff. Do we have any question on this?
None at the moment.
Okay. Actually want us to do a real-time collaboration. So if we need to do all of this installation so that we can like collaborate in real time, you see my code and I see your code, stuff like that. So we really need all of this installation moving forward. So it's going to take a while to do all of the installation anyway, but I think we'll just have to. Then we're also going to be, I'm going to be sharing some resource for Python because of our time constraint, we might not be able to go really deep into Python because Python essentially is just a means to an end. The purpose of this bootcamp is to actually know how to or learn how to build backend application. So Python is what we're going to be using as a programming language, but we're not just stopping at with Python. We're going to be learning Django too. Django is for is the framework for backend web development. So we have a lot to learn. In the meantime, I'm going to be sending us some of these resources. You can actually learn certain things from them before we meet next week. Then there are also some links I'll be sending during the week, for other resources. How far have we gone with the installation? Comment, please. How many of us have a GitHub account? Do we have a GitHub account? Wale, you asked if we're on break.
I noticed everyone is muted, so I wanted to know, are you just waiting for installation completion?
Yeah, actually, we wanted everyone to be on the same page because we needed that for the next phase.
Okay, all right.
But did you see the message dropped in the WhatsApp group?
Yeah, I'm just installing, right? Sometimes some of this installation takes time, so yeah.
So what stage are you on now?
Yeah, I had issues with the first one, so I just done with the Jupyter Lab, so I'm about to. I have I have notebook already, so I'll just go to the next one. Yeah, so I have some of them. So I'm just picking it out. Yeah, but I'll let you know when I'm done with everything.
Okay, fine. Dominic, maybe he's off. Dominic, are you there? Okay.
While we are waiting, you might want to take time to explain some of these, things that we are installing and their usefulness.
Yeah, the problem is it seems like some people are off, like they're not listening. So I just actually wanted everyone to be on. But in the meantime,
Okay, but it's being recorded, I guess.
Yes, of course, we have.
Yeah, and then the recording is going to be available to everyone, right? So
Yes,
if
yes.
someone is for some reason unavailable because they are doing some other things, yeah, that shouldn't stop the class as long as we have it's recorded or you have one at least somebody responding to you because we have a timeline for the class, right? And we don't want to go beyond the class time too.
Oh, exactly. You're right. Absolutely right. So let's just move on. So for Jupyter Lab, it's just a software that works for it's a collaborative software. So it helps with tools like Notebook. You can actually have Notebook inside Jupyter Lab. You can have terminal set up inside. You can even have text editor. So what Jupyter Lab allows us to do is essentially collaborate with other folks, and then it just has these integrated tools built in, some via installation where you can have all of the things you need as a developer, particularly Python developer. It allows you install other packages too, like for data science and all of that. So then Notebook, Notebook also helps us write markdowns and code simultaneously. During my presentation, I was using a notebook to present. So it helps you run your code in line with markdown files, and then they are also exportable. So it's very, very useful tool. It even helps with data visualization and all of that. So then we have Jupyter Lab for Git. So Jupyter Lab for Git, what it does is essentially helps us do version control in Jupyter Lab. No need to export your files to your local machine via Git. You can just run Git command by clicking buttons, the user interface, and then you have your version control ready. We're going to be talking about Git and GitHub later, subsequent classes. Then we have Black and ISOT. So Black is basically a package that helps you format your code in Jupyter Lab. It just helps you format your syntax very nicely. We also have another one, the code formatter. Then we have the LSP server. This is another powerful one. It helps you detect errors and auto-completion of code. So essentially, those are the major ones for now. In time to come, we'll do more installation as we progress. We don't want to make it overwhelming for some people because some are just beginners here. So these are the ones we need for now. By the time we pivot into Django properly, we will also do some installation. Okay.
All right, thanks.
So I'm going to share my screen now. What I actually wanted to do was to have a walkthrough on how these things work. So it's very important to have everybody. But since we can't do that now, let's just move on. I'm going to share my screen, and we're going to do like a walkthrough. Okay, can you see my screen?
Yes.
Okay. So basically, if once we have all of those things installed, we can do Jupyter Lab. Once we hit this command, it's going to spin up an instance of Jupyter Lab, which this for instance. So this is what you're going to see once you spin up that command. Once you hit Jupyter Lab, hit enter, it's going to spin up an instance. And this is how the interface looks like. So I'll just quickly do a walkthrough of the interface. So over here we have this plus button, helps us create terminals, text file, markdown files, Python files, and the likes. So depending on what you want to do, if you set up a Python kernel, this Python kernel will create an instance of a notebook in Jupyter Lab. So this is an example of a notebook. This is what I used for during the presentation for Python, right? Now, we also have, like I said, terminal. You can spin up an instance of a terminal in Jupyter Lab. So this is an instance of a terminal, and then it has its own settings. You can actually change the scheme to maybe a dark scheme, color scheme, theme rather. Then from here, now this takes me directly into the folder structure, but sometimes it just open it at your user stage, then you navigate into the project directory. Let me quickly go back. So let's say it takes you here. Once you spin up, it takes you here. Then you have to navigate. You have to see into the project directly. Like for this project, you can actually create folders as well. If you come down here, I have Maxify Bootcamp, and these are the content for week 1 and week 2. So you can actually create a folder using the folder icon, then create different subfolders before you now begin to create your notebooks. Then for text file, I already have one for this Conda installation. This is also an example you can rename and all. Then we can also do Python files. So you can essentially create a Python file and run a command. So for now, this is a Python. This is like a text editor. Inside the Jupyter Lab, you can start writing your code here. And when it's time to execute, all you need to do is probably open up your terminal and then run it from there. We're going to be using this subsequently as well. Then we have your console. This helps for interactive coding. Then we have the markdown files as well, if you want to write markdown files. So these are all the things you can do for now. There are some of the things, but these are the basic things we're going to be using this software for. One, we're going to be using it to share materials. We're going to be using it for collaborations. I can actually come down here and share. So once I share this link, anybody that has the authentication token can actually log in and we can share code together, right? We can work real time. So that's what we're going to be doing essentially for class taxes and all. you have any questions for now? Anybody has any question?
Hello, sir.
None at the moment. Although my network went off a while ago, but I'm back online.
Okay.
Yeah, I have a question. Is there
Okay,
any
we'll
way
see.
after the classes we can have like a recap or video of this same class we just attended?
Sorry, it's not clear.
I said, can we still have the recording of this class we are attending now?
Yes, of course.
Okay, because there are many things I need to go through again so that for better understanding. Because I just landed at my destination.
Okay. That's fine. Wally, do you have any question so far?
No, sir.
Okay, thank you. So that's fine. Aside from Husseini, Dominic, have you done your installation? Are we on the same page with that?
So I'm on code formatter.
Okay. So essentially, I just did, maybe you were not on then, I did a review of what all of those tools are supposed to help us do. They're supposed to help us with collaboration, make our code look better and all. And yeah, next week, we're going to be doing some live classes. When we give assignments, it's expected that we use these tools for our assignments, you know. So, and then for real-time collaboration, I'm also going to be sharing some of like the course materials using this tool. And then when we get a bit advanced, we might have to port to other tools like using VS Code properly by the time we get to Django and all. So we might, because for Django, Django doesn't integrate very well with Jupyter Lab. So we'll have to create a separate development environment for that. But the VS Code we've installed and the Python we've installed probably yesterday would suffice for now. Any other installations will be communicated in due time in the chat. So yeah, now I just want to share my screen and go over certain things before while we wait for the installation. Did you meet the part where I showed how to launch the Jupyter Lab instance? Dominic.
No, I didn't meet that part. Although I met when you were moving through the interface.
Okay. Essentially, can you see my terminal?
No, I can't say.
Okay. How about now?
Yes, I can see it.
Okay, so once you do all the installations, right, you can just hit this command, Jupyter Lab, and then you can get it will spin up an instance. Once you hit that command, it spins up this web-based user interface. It's actually a web-based user interface. And once you do that, it's going to show you spin up this bunch of logs. So these logs essentially it's just outputting all the things you're doing on the platform, like on the interface. You know, it's a server on its own running on your local machine. So it spins up all of this log to tell you what's going on. and it actually has some tokens. We'll get to that part if it's necessary. Okay, so make sure you're in your base environment. Anytime you're doing a Conda installation, make sure you're in a base environment, so that everything will be installed properly.
Okay.
Yeah, these materials will be sent across so that we can open it locally in our machines. The resource for this today's class, then including some of the books. I want to ask a general question now. So I know some of us prefer videos for learning, some prefer books, some documentation. I want everyone to tell me what is the most preferred way we learn stuff.
Okay. To me, I prefer the videos because
Sorry?
I prefer the videos.
Okay, videos.
Yeah, the video tutorials.
Okay. Dominic?
Videos are fine by me.
Videos, okay. Wale, are you there?
Yeah. You were asking if you prefer materials or videos, right? Hello?
You said, sorry, I didn't get you.
I was asking you a question. You were asking if you prefer videos or materials.
Yes.
I think a combination of the two is fine.
Okay. So that works.
Yeah.
We're going to be, of course, these videos are recorded, and then subsequent classes, we're going to have 2 sessions. The first session is going to be the theoretical part, where we just explain basic concept about what we're going to be doing. And then the second part is going to have the code, practical writing of code in real time, and then explaining what the code is doing. So it's going to be, the learning curve is going to be steep. So, but that's why we have support. Even during the week, assignments will be sent, and we expect that if you have any question with implementation, you can always ask questions, right? And do further study. The truth is, what we're going to be delivering is the maybe 30% that is going to make you have 80% of productivity. So that's the ratio. It has to do with self-motivation and self-learning, checking things online for solutions. And when you're doing your assignments, you're going to be facing some challenges, obviously. So before you ask, just in the chat group on WhatsApp, our advice, we just check online or other ways before we actually ask, because time is very, very important. So let's manage it properly. Then aside from that, we're going to be doing project-based learning. There's going to be a capstone project where you're going to be working across board with other teams of front-end developers in the coming weeks. Looking forward to that. Meanwhile, the Django proper we're going to be building some projects. So it's going to be a project-based learning. So first part is the theory part that briefly explains what we're doing, and then we now go into the live coding. And that's why we need real-time collaboration, because I would want you guys to also be imputing code and then seeing what I'm doing alongside. Then for the projects, we're also going to be making use of GitHub to deploy some of our project work. For those of us who don't know what GitHub is, it's just a platform for storing our code, online remotely so that other people can access and then collaborate. So we're going to be doing that as well. And what else? Is there any other thing I'm missing? And then for the back-end framework, for the actual web application we're going to be building for back-end, we're going to be using Django. There are so many of them. We have Flask and all. Now, for the web application, there are two parts to all of these things. There's the API part where you're essentially going to be creating endpoints for the front-end guys to consume. And then we have the traditional approach where when you build the application, it's going to have everything inbuilt in terms of the templating. So you don't have to, it doesn't have to consume any, you don't have to write endpoints to be consumed by the front end. So we're still trying to see which approach will work best for us, because for the collaboration, if you're collaborating with front-end guys, it means that you definitely are going to be writing APIs, endpoints, right? So the front-end guys can actually consume the API so that to make the application work. So you're dividing, separating the concerns. So Django has that functionality. Then it also has the traditional approach where when you build, let's say, a blog, for instance, it does everything from the templating to, that's the front end, to the server side code, what the users see. You don't really need an endpoint for that. So we're going to be, best scenario is to merge the two together. So when we build a project, we're going to do the first version, which is the traditional one, and then we're going to do the second version, which is the endpoint. So as we're building along, we're going to be adding APIs to the project. Does anyone have any question to that?
Yeah, I support that. We should do the two.
Okay. That works. Has anyone built any web application with a backend framework other than Python before? Okay, I guess it's no. So,
Yes, I said no.
okay. Wale, any application with build anyone?
No.
Okay.
No.
Okay. So that's cool. Are we done with the installation? Dominic, are you done?
Yes, I'm done.
Okay. Have you been able to spin up an instance of Jupyter Lab?
Yes, I did. And it worked fine.
Works fine, right? Okay.
Yes.
So I guess Wale too has been able to do that. So for the learning materials, right? I'm going to be sending some basic book about Python, and then as well for Django, maybe 2 or so, for those who would want to learn visually. Then for the videos, I'm going to be recommending some channels, YouTube channels for us with good quality during the week. that we can actually check, and learn from there so that we can have the both approach. Actually, for beginners, when I started as a beginner, I also preferred videos. So at first, because you really want to see how everything is working and the code and all. But as you begin to develop over time, you would have to pitch, your preferences would now have to change. Maybe from videos to documentations, because most of these programming languages or libraries, they have documentation, right? So you go there to read about how to use the software or the library or framework, and then books too. Lately, I'm more of using books to learn new stuff because I just feel it allows me learn at a pace, and then I can always keep. It's just maybe my present preference has actually changed, but video is also very good for beginners and all. So we're going to be combining the both of those content forms for learning materials. Then I'll also encourage us to check documentation, be curious, check documentations as well to just get an overview of what those things do under the hood, right? Now, the reason why we're going with Django essentially is because Django has everything. It's like a framework with batteries included. That's the description they gave about it on the website. So it just helps you with a lot of things out of the box. And you don't really have to worry about so many things to include, because if you're building a web application, it has a lot of things that needs to go work together, right? You need to work with your database. You need to find how to get users signed up. You need to do a lot of things. So Django has that capability it just helps you decide a lot of things from the beginning, right? So, and that leaves you with a steep learning curve, but that's why we are here to clarify things. Once you understand how a project is being structured and what each of those folders are doing and files are doing, I think it will be very, very easy to go with that route, with that approach. So that's what we're going to be doing. Then for next week's class, we're essentially going to be looking at give me a second. So for next week's class, we're going to be looking at control flow, sequences, selections, loops. We're going to be looking at complex data types, list sets, tuples, and classes and objects. I really don't want us to spend so much time with some of these concepts because these are things we can do on our own during the week, right? Where we're going to be spending a lot of time with is when we now move into Django development, because that's where the real work is. We're not even going to be, we're just going to be using some of these programming concepts in the process of creating a Django web application. So you don't really have to become an expert in Python to be able to write Django. So these classes we are having on Python is just like a crash course where we just get to understand the basics, right? How these things fit together, just the construct. Once you don't even have to be an expert. Once you just familiarize yourself with some of this construct, then we now go into Django development. And yeah, I feel that way will be better. Then what we're going to be doing essentially with Django is building functions and classes. Those are the things we're going to be doing essentially. And then this idea of control flow will help us when writing a Django application, because just like programs are all about inputs, processing, and outputs, like I showed us in the previous diagram. There's also an algorithm actually has three basic aspects. One is the sequence, two is the selection, three is the loop. So the sequence essentially handles the flow of your program. Selection is basically your conditionals, and then the loop. So once you have an overview of all of these things, when I begin to write a Django code, or when we begin to work on those web applications, you understand the sequence and how everything works together. So pretty much that's that. So do you have any questions so far?
No question from here.
Okay.
None from my end.
Okay. Husseini, are you there?
Yes, sir.
You have any questions so far?
No, for now.
Husseini, are you there? I can't hear you.
No.
Okay. So in the absence of questions, we are essentially done with today's class. It's just an introductory class. And I'm going to be sending assignments our way latest by Monday. I'll encourage us to also the material for today will be sent, like I said initially. Then I'll encourage us to check some of those things we discussed on our own, do your research, and one thing I didn't mention when I was talking about those programming constructs is the fact that you can perform operations on all of these data types. Like for instance, the number data type, you can perform operations with them, and they have their methods, right? And so I'm going to be sending assignments in that regard. We're going to be writing some code essentially on manipulation of some of those basic data types. So instructions of how to solve those problems will be stated in the assignment. So you're going to be performing operations on strings, on numbers, and the likes, declaring functions and all of this stuff. So let's try to read the material in addition to what I'll be sending for the assignment. If you have any question, you can drop on the group regarding that. So I think that will be the end of today's class. Thank you very much for sticking till this time. The more as we get into the training, we're going to be doing more advanced stuff, so let's stay motivated. Let's be optimistic. At the end of the day, we're going to achieve our goals. So thank you very much, everybody, for your time. See you next week, and then in the chats group on WhatsApp as well. Yeah, I was saying it.